Alright, hi everyone. So welcome to the fifth lesson and also the last lesson for our topic 5 integration. So for today's lesson, we are going to look at the last integration technique, which is called as integration by parts. Okay, so it might get a little bit tricky at first when we started to learn the formula, but as you continue to practice and you get the idea for how the formula works for you, then it will be totally fine after that. Okay, so before we move into today's focus, let's spend 15 minutes to finish off the part that we left in the last lesson first. Okay, so you should take out your last handout before you move into this lesson 5. All right, so we have left with this part, which is called as two standards form for partial fractions. Okay, so it's not going to be a very hard one. And I need to say this, even though you are not using this formula, you still can get the exactly same answer with the technique that you have learned in previous lesson. Okay, so it's just that with this formula, then you do not need to do the partial fractions expression where you can straight away from this integral, you can straight away get your answer. Okay, so let's try to look at how is the formula derived from. Alright, let's try to look at the first one. Consider the integral 1 over x squared minus a squared dx. So when you look at this integral, you know that you need to express it in partial fractions before you can start your integration, right? So let's try to express it into partial fractions first. Okay, so 1 over x squared minus a squared. So when you express it into partial fractions, you know that you need a minus x minus a plus b over x plus a, correct? Because x squared minus a squared is basically equal to x minus a, x plus a, right? Okay, so now let's try to solve this. So 1 equal to a multiply with x plus a, and then b x minus a. So when I substitute x equals to a, I will actually get 1 equal to a multiplied by 2a, which gives me a equal to 1 over 2a. Okay, so when I substitute x equals to negative a, I will get 1 equal to b multiply with negative 2a, which gives me b equals to negative 1 over 2a. Okay, so now let's try to substitute back into the integral. So meaning that when I try to solve 1 over x squared minus a squared, I will be actually solving a, which is 1 over 2a, right? So 1 over 2a, x minus a, plus, but b is negative, so that's why you straight away put minus 1 over 2a, and then x plus a. Okay, then you need to integrate with respect to x. So now you can see that you have both you have both constant for this integral. So 1 over 2a, and then integrate 1 over x minus a, and you have second one, which is minus 1 over 2a, then you need to integrate 1 over x plus a. Alright, okay, so now as we continue, you can realize that 1 is the derivative for x minus a, which this is in the form of f prime x over fx. So same thing, 1 is also the derivative for x plus a, which gives you f prime x over fx also. So that's why we can try to integrate it into ln. So ln x minus a minus 1 over 2a ln x plus a. Okay, and then don't forget plus constant. So if we try to simplify this, then you can see that I have both 1 over 2a, right? Alright, then after that, for these two ln, I can always combine them together. So this is minus, so it will become ln, and then x minus a over x plus a. Okay, So this is the first formula. So meaning that if I have a form of 1 over x squared minus a squared, I do not need to go through the process of partial fractions, which I can always just substitute by using this formula. Okay, so we'll be looking at some example later, don't worry. But okay, maybe let me just show you like a very quick one. Let's say if I have 1 over x squared plus 2 squared. Okay, so when you look at this, then maybe you need to find out like the partial fractions first before you can continue, right? But with this formula, then what you can try to do, your x is x, which you can see x squared and x squared. So a squared is actually 2 squared. I'm sorry, this is supposed to be minus. So minus 2 squared dx. So you can see what's your a here. Your a is 2, correct? So that's why I know that the integration for this will be equals to 1 over 2 multiplied by a ln, and after that x minus 2 over x plus 2 plus c. Okay, so this is like a formula for you to, for to ease the process so that you do not need to go through the partial fractions to get to your answer. But as what I say, if you forget that you have this standard form and you actually do partial fractions, you actually get the exactly same answer. So don't worry about that. Okay, so now by using the same technique that we have done just now, I want you to try out to derive yourself for the second one, and you try to get the formula which is given here. Okay, so just now we tried to derive this one already, right? So I want you to try out the second one and you try to derive this one by yourself. Okay, so I'm going to fast track my process, then after that you try to check your answer whether you can get this or not. Okay, I hope that you can derive everything. So the idea of this is that you must make sure that the numerator is the derivative of the denominator, right? So that's why this should be negative one instead of a positive one. Because when you when you differentiate negative x, you should get negative one. Okay, so now let's try to look at the example 9 here. Okay, so example 9, let's try to do the derivative. So you must make sure that when you use this formula, right, so the coefficient for x squared, it must be always equals to 1 only. Okay, so that's the thing that you should check, and then the numerator must be 1. So for a here, so it's very simple. What we need to do is to do the factorization. So take out the 2, and after that in your denominator, you should get 3 squared minus x squared. Okay, so this is in this second form, which is a square minus x square. So that's why you have 2, and then after that you can start to substitute it. So what is the what is the a in this integral? You have 3, right? So that's why 1 over 2 multiplied by 3 ln 3 plus x, and then divide by 3 minus x. Okay, so now let's try to simplify our answer. So you have 2 multiplied with 1 over 6, which give you 1 over 3, and then after that ln 3 plus x, 3 minus x. Okay, as simple as that. Okay, so let's move on to B. Okay, for B, you can realize that the coefficient for x squared is not 1, it's 4. So the first thing that we need to do is we need to do the factorization first as well. So 1 over 4, then I have 1 over x squared minus 9 over 4. Okay, so I have the coefficient of x squared now to become 1 already. So now let's try to express the 9 over 4 in the form of a squared. So 1 over x squared minus 9 3 over 2 square. Okay, so now this is in the form of 1 over x squared minus a squared, so I can continue with this formula. So 1 over 4, and then 1 over 2 multiplied by 3 over 2 ln. So x minus a, so x minus 3 over 2, and also x plus 3 over 2. Okay, so the next thing that we need to do is to simplify this part. All right, so you have, oops, sorry. Okay, so 2, you get 1 over 3, right? So 1 over 12, and then ln. So when you combine this part, then it will become what? 2x minus 3 divided by 2. And then for the below part also, 2x plus 3 divided by 2. Okay, so since you have both part divided by 2, so we can always simplify it. So ln 2x minus 3, and then 2x plus 3. Alright, so that would be your answer. So some interesting thing about this formula is when you try to check it, right, you can see that x plus 3 and x minus 3 is basically the quadratic factor for 9 minus x squared. So what is 9 minus x squared? 9 minus x squared is actually equals to 3 plus x multiplied with 3 minus x, right? So the same thing, you can see 2x minus 3 and 2x plus 3. When you multiply them, you get exactly 4x squared minus 9 also. Okay? Alright, so move on to C. So you have this. Yeah, so you can see that the difference between these questions and A and B is that for A and B, right, your numerator only contains of constant, which you can always simplify it by doing factorization. But for this one, right, you have a x squared plus 1 at the top. So how are you going to do that? So when you look at this one, right, for now, you should be able to identify this as an improper fraction because they have the same degree, meaning that the highest power for the numerator and the denominator is actually the same, which is 2. So that's why to start this, we need to do a long division first. So x squared plus 1 divide by x squared minus 1. So what do you get? So you have 1, then after that x squared minus 1, right? So 1 minus 1, you get 2. So that's why from here, we know that to integrate this, we need to do 1 plus 2 over x squared minus 1. So you can realize that this form become what we want already. So integral for 1 dx plus 2 and then 1 over x squared minus 1 squared. So now you can use the formula for this part. But then, yeah, as what I said, if you didn't realize that this is the standard form for this formula, if you go on and do long division and then after that you do partial fractions, you will get the exactly same answer. So don't worry about that. So integrate 1, you get x and then plus 2. So your a is 1, right? So 1 over 2 multiplied by 1, then you have ln x minus 1, x plus 1. Okay, the whole thing plus c. So x plus, so 1 over 2 multiplied, then you don't have, you just left with 1. So x minus 1, x plus 1 plus c. Okay, so that will be your answer. So move on to D. So the finite integral here, so 1 over x squared plus 4 dx. Okay, so for these questions, right, can you continue to do the 1 over 2a ln x minus ax plus a? Yeah, so if you are not aware of this, then you might continue with 1 over 2a, then after that ln x minus 2x plus 2. So my question is this correct? So when you check it, right, you see that where for this part, right, x minus 1 and x plus 1, when you multiply them together, you get back the denominator here, which is x squared minus 1. But when you have this, right, you see, when you try to do this, then after that, when you multiply them together, you are not getting x squared plus 4. And then the other thing is, you try to think after that, when you try to substitute, right, you will get something wrong if you continue. Yeah, so this question I'm just putting here as a trick, so to remind you guys that you must check that it's always in the form of x squared minus a squared or a squared minus x squared, then only you can use this formula. So for this part, you can see that this is plus, not minus. So that's why this is not the standard form in partial fractions. So how do we do this exactly? So this is the one that we actually do tangent negative 1, if you still remember. So this is 0 to 1 over x squared plus 2 squared, which is what we have learned previously. When you integrate 1 over x squared plus a squared, then what do you get? You still remember this formula? So this is the tangent negative 1 formula, which will give you 1 over a tangent negative 1, then x over a. So make sure that you are not confused with these two. Okay, so for tangent negative 1, it always do with plus only. So for the two standard forms that we learn for partial fractions, it's always minus. So that's why for these questions, it should be 1 over a, which is 1 over 2 tangent negative 1, and then after that x over 2. Okay, and substitute 0 and 2. So as you continue to do this, you should able to get 1 over 2 tangent negative 1 1 minus 1 over 2 tangent negative 1 0. So your answer should be 1 over 8 pi minus 0, which gives you the last answer, 1 over 8 pi. Alright, so that's it for this part. So we are going to move on to the very last part for integration. Okay, for your information, in the last part for your handout, I have actually put in all the integration formula that we have learned, and also those will be given in the exam in your handout. So please try to check it out. So what is the thing that maybe is not given and you should memorize by yourself. Okay, so yeah, so this is a formula that I mentioned just now. So make sure that you know, like when it's plus, then the integration should be tangent negative 1. So when it's minus, then only you can do the standard fractions that the partial fractions one that we have learned today. All right, so let's move on to our focus for the day, which is integration by parts. Okay, so you can see, right, consider this integral. So this function can be seen as is like a product of two simple functions, which is x and e to the power of 2x. So if let's say in differentiation, when we look at this function, right, so the first thing that we are going to do is we will use product rule. So we treat this as u and v. Then after that, we continue to differentiate it by using product rule. But then in integration, we don't have such thing like product rule. But previously, we have learned the part for how do we actually do integration by using substitution. But for in this case, right, you can imagine that if you are going to do substitution, right, it wouldn't help in this case. Yeah, maybe you want to try it out by using like u equals to x, or u equals to 2x, or u equals to e2x. You can realize that no matter how you change, right, because when you do u equals to e2x, when you substitute x, you have a ln coming out as well, and you can't integrate a ln. And then after that, you will realize that it wouldn't help in this case. So that's why we will try to use integration by parts, which is the integration by the product of two functions. So it is something similar as if like the product rule in integration. But of course, we are not going to use exactly the same formula that we use in differentiation. So now let's try to derive it. So how is that going to look like? So we know that for the differentiation y equals to uv, we know that the dy dx will be equals to u dv dx plus v du dx. Okay, this is what the product rule state. So now let's try to integrate the whole equation that we have here. So when I integrate dy dx, with respect to dx equal to integrate u dv dx with respect to x plus integrate the whole thing for v du dx with respect to dx. Okay, so meaning that I integrate both sides. All right, so now when I continue, what do I get? So when I integrate dy dx, right, what can you imagine that you will be getting? So you know when you integrate dy dx, you should be able to get back to y, right? Then after that, I have u dv dx and v du dx, which I can't continue to do anything here, so I'll just copy it. Okay, so now you can see that for the equation, the term for my right hand side is all in the form of v, u, and also x. So I have a y here. So is there anything that I can substitute for the place for y? So we know that y equals to uv. So that's why uv equal to integrate u over v dv dx with respect to x, and then after that plus v du dx dx. Okay, so now let's try to rearrange this. Okay, because we want to also get something that's like integrate a product of two simple functions. So that's why we try to exchange the place for this and this. So what do we get? We get the integration for u dv dx with respect to dx will be equal to u v minus v du dx dx. Okay, so meaning that I'm changing this into the front part, then I rearrange the whole thing. All right, so this is the formula for integration by parts. So meaning that what we are trying to do is we treat our integral here as two parts, meaning the first part is u and the second part is dv dx, and the formula is going to be uv minus the integration for v du dx. Okay, so now let's try to explore this formula in a more detailed way. So if you have your highlighter, then you can use your highlighter over here when I try to explain it. All right, so when we look at this formula, right, can you tell me that for the part for u, what is the further calculation that you are going to deal with it? So for the u, right, as you see when you continue, you will need to write the exactly same thing here. So if this is u, then this is the same thing over here, which is u. Then after that, you have a du dx. How do you actually get du dx from u? You will need to differentiate it, correct? Because u to du dx, you differentiate. So that's why for the u, it must be something that can be differentiated. So meaning that it must be something that you can differentiate. Okay, so now let's look at the second part. So this is dv dx, correct? So for dv dx, what are the further calculation that you are going to do? So for the dv dx, when you move on, right, you are going to write v only. You realize that you didn't put any dv dx in the formula. What you need? You only need v. So what do you need to do so that dv dx can become v? You need to integrate it, correct? So meaning from dv dx to v, you should integrate it. So that's why for your second term, it must be something that you can integrate. Okay, so if you have your highlighter, right, I want you to actually highlight here. So v must be a function that can be differentiated. dv dx must be a function that can be integrated. Okay, so let's try to move on to the second tips here. Okay, so when you see, right, the example that we have here, which is x and e to the power of 2x. So x and then e to the power of 2x. So when you look at these two terms, right, you can realize that both of these can be differentiated and can be integrated as well. I can differentiate x, right, and I also can integrate x. I can differentiate e to the power of 2x, and I can always integrate x e to the power of 2x as well. So if you have a choice, how are you going to do that? So you see, for this formula, right, when you try to put in uv, that's the end of your calculation already, meaning that you are not going to do any further calculation for uv. I mean, maybe you need to do simplification and so on, but you do not need to do a further differentiation or a further integration. But when you look at this part, right, after you substitute your v and du dv, you are going to integrate it again. So meaning that our target here, right, for the part for v du dx, it must be something that is simple enough for you to integrate. Okay, so you might have the case where you need to do your integration more than once, but then our target is to keep this part as simple as we can so that we can always integrate it, then that's the end of it. Okay, so let's try to see this. So we are going to look at, so this is actually our example 1, so I'll try to explain further from there. But something that you remember is, if you do not have a choice, then for your product, then you must, when you try to fix which one is u, which one is dvdx, you must make sure that the u must be something that you can differentiate. dvdx must be something that you can integrate. And then if you have a choice, meaning that both of your term can be both differentiated and integrated, you should try to make your v du dx as simple as you can. Okay, so let's try to see how is that going to look like. So let's try to look at example 1. Okay, so some tips for you for now is, you must make sure that you are very familiar with all the differentiation and integration before you move on, because you will need to do differentiation and integration at the same time when you try to use this method. Okay, so you must be like quite careful in this. Okay, so let's try to look at example 1. Okay, 1a. So let's try to look at the part where how do we actually identify which as u, which one as dv dx first. Okay, so maybe I'll try to write down the formula here. So you have u dv dx. Okay, dx, then you will actually get uv minus v du dx. Okay, so now you have a here. So you can see a and e2x, right? They are they are both differentiated and integrated. So how can you actually identify it? So I'm going to explain this part. So for x, right, can you try to tell me that if you are doing to do differentiate, what do you actually get? You get 1. Then when you further to do it, then you will get 0, right? So when you try to do integrate, right, what do you get? So from x, you actually go to x squared over 2. Then when you integrate again, you are going to get like x power 3, then divide by 6. Okay, so you can see for x, right, it obviously that when you do differentiation, you get a simple one, right? So for the when you do integration, you are going to get a more complicated function. Okay, now let's look at e2x. So for e2x, when you try to do differentiation, what happened? So you will get 2e2x. When you further to do it, you get 4e2x. So for integration, what do you get? You get 1 over e2x. Then after that, you get 1 over 4e2x when you try to further to do it. So you can see that for the function of e2x, right, whether you do differentiation or integration, for the function with containing x, right, is going to be always the same. The different thing is just that the coefficient in front of it. You can see that you still get e2x, 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 no matter how many times that you are going to do. So that's why if we want to try to keep this step as simple as we can, right, what do we try to do? We will try to choose this. Because these two is going to be roughly the same for me. So no matter which one I choose, it's going to be like as simple as the original function. So that's why the one that can be differentiated, I will choose to be x. The one that can be integrated, I will choose to be e2x, because I do not want to deal with a complicated functions over here, where you can see if I continue to make this very complicated, then I cannot integrate it as well. Okay, so that's the idea. So some tips that I have put in your notes is that if you have an integral in the form of x to the power of n and fx, right? Normally, if your fx is an exponential function, so meaning like just now we have e2x, or you have a trigger function which is sine or cos, we always put our fx, meaning the the dv dx part, as the exponential or the trigonometric. Okay, so let me try to do the first example, then after that you can see this like clearly. Okay, so as we have x and e2x, so that's why we will try to put our u as x. Okay, then after that our dv dx will be e to the power of 2x. Okay, so now you can find the differentiated form and the integrated form first. So for u equals to x, du dx is actually equals to 1. Okay, differentiate. So now dv dx, you need v, right? So v. So you need to do integration. So that's why you must make sure that, you are very clear with all of this, because you need to do differentiation for the first one and integration for the second one. Okay, so when you integrate e to the power of 2x, you get 1 over 2e 2x. Okay, so now we can try to put them back into the formula. So integration for x, e 2x dx will be equal to uv. So u and v, when you multiply them together, you get 1 over 2x e 2x. Okay, u multiplied by v, uv. So minus, so what is your v? So your v is this part, right? And your du dx is actually this part. So you are going to multiply these two now. So it's like these two first, then after that these two. So 1 over 2e 2x. Okay, and you should realize something, that for this term, right, you realize that it becomes something that you can integrate already. So 1 over 2x e 2x minus, can you integrate this? Yes, you can, because this is like just a constant, right? So if you want, you can try to take it out first. Then after that, e 2x, then dx. So now we try to continue with the integration part. So what do you get over here? So you will have 1 over 2 multiplied by the integral for this part, 1 over 2e 2x. Okay, and then plus c. So 1 over 2x e 2x minus 1 over 4 e 2x plus c. So that is our answer. Okay, so if you want, then you can further what's that called? You can try to further simplify it. So you have 1 over 4 and 1 over 2. So you can take out 1 over 4 as well. And then after that, e2x. So for you to get back inside here, then you will need to multiply with 2. Then after that, x minus 1. Okay, so if you want, then you can try to simplify in this formula. Alright, so that's the idea. So you can see that the idea is how do we actually fix the u and dv dx, so that for this term, it becomes something that you can integrate, then you can continue. Okay, so now let's move on and see b. Okay, so the same thing, let's try to change it into the form of product of 2 first. So 2x, and after that you have e negative 3x. Okay, so now the same thing, you need to decide which is your which is your u and which is your dv dx. So as what I said, normally if you have exponential and also trigonometry, the functions of exponential and trigo will be your dv dx. Okay, so it's the same thing for like a and b, right? You can try out if you try to exchange this two part, and you try to put this as u and this as dv dx. You can try it and see, and you will realize that you will have some issue that you or actually after you substitute, you can't integrate this part as well. Okay, so you can always try that out so that you can understand it better. Okay, so now the same thing. So your u, we try to fix it as 2x. Okay, so your dv dx is actually e to the power of negative 3x. Okay, so the same thing, differentiate it first. So du dx will be equals to 2. And then after that, integrate this, then you get negative 1 over 3e negative 3x. Okay, so now by using the formula, just substitute everything. So 2x over e 3x dx will be equal to, so uv, so negative 2 over 3x e negative 3x. Okay, then v du dx, same thing. So I'll try to multiply them straight away. So if you think that it's your first time and it's still very not so familiar with it, then you can try to write this out first lah. So 2x multiplied with negative 1 over 3e negative 3x. Okay, then multiply the integration for these two. So you have v is negative 1 over 3e negative 3x. Then after that, you have your 2. Okay, then after that, dx. So now you can continue with it. So negative 2 over 3x e negative 3x minus, so you combine these two together and you should have a plus 2 over 3. Then what do you need to integrate? It becomes negative e negative 3x only. So you can see instead of like solving this, now the integration, no, is I mean that of course there are different things because we try to implement the formula here already, right? But the idea is that when we try to use this method, right, for this part, it will always become a simple integral that we can directly integrate. So negative 2 over 3x e negative 3x and then plus 2 over 3. So when you integrate this, what do you get? Negative 1 over 3e negative 3x, right? Then don't forget your plus c. So when you continue, so let's try to just simplify your answer. So 2 over 3x e negative 3x minus 2 over 9e negative 3x plus c. Okay, so same thing, if you try to simplify your answer, then you can try to make it in the term of like negative 2 over 3e negative 3x. Then after that, for you to get back to this, then what do you need to multiply? So from 2 over 9 to become 2 over 3 is actually multiplied with 3. Okay, then after that, you have x and then plus 1. So that will be your answer for this question. Alright, yeah, so number 1 and 2 is quite simple. They are similar. So the idea is for you to understand the idea. So it will get much more difficult when we move on. So let's try to look at C. Okay, C. So by now you should be able to roughly understand how to use this formula already. And don't worry, this formula will actually be given in your exam. So you can check out the formula in your handout. So it's in the last formula. Okay, so for number C, this question is the question where you don't have any choices for your u and dv dx, because for the part for ln x, you can only differentiate but you can't integrate it, right? Because when you differentiate ln x, you get 1 over x, but you can't integrate ln x. Okay, so that's why for this part, for your u, it must be your ln x. So meaning that instead of solving this, we will be looking at ln x multiplied with x. Okay, so meaning that this will be your u and this will be your dv dx. Okay, so u equal to ln x and then dv dx equal to x. Okay, so differentiate first. So du dx will actually give you 1 over x. So for this part, it will be your v. So integrate. So integrate x, you will get x squared over 2. Alright, so now let's move on. So we can try to put this in the formula that you have already. So x ln x dx will be equal to, so u times v, so you have x squared over 2 ln x. Okay, and then multiply. Now it's these two, right? So we try to write this first. So your v is x squared over 2, du dx is 1 over x. All right, so now let's try to simplify that part. So you have minus, so x and x squared, you can always simplify this. And what do you get? You get x over 2. So in another word, 1 over 2x. So now you see this is something that you can integrate as well. So you can 1 over 2 x squared ln x minus, so can you integrate this? Yes, you can, right? So it will become 1 over 4 x power 2. Okay, and then after that plus c. So this will be your last answer. So same thing, if you want to simplify your answer, then it will be 1 over 4x squared multiplied by 2 ln x and minus 1. Okay, all right, so that's C. Yeah, so you see it's actually not very difficult. So you just need to like identify your U and dvdx, and you should know how to continue. So we'll look at one more simple example, then when we go to then move on to Trigo. Okay, D, how do we actually do this? So you can see that you don't have, this is like not a multiplication between two functions, right? And you need to solve ln 2x. And obviously you can't integrate a natural logarithm function. So how are you going to do that? So we can just try to do this. So ln 2x is actually the product of 1 multiplied with ln 2x. Okay, then after that we will continue with this. So you can see the same thing. So your ln 2x cannot be dv dx because you can't integrate it. So that's why what we are solving ln 2x multiplied by 1. Okay, so now your u is actually equals to ln 2x. Okay, and then your dv dx will be equals to 1. Okay, so for now, if you think that you are quite familiar with this formula already, then you can always try it out yourself, then after that check your answer. Okay, so for ln 2x, when you try to do differentiation, you will be getting 2 over 2x, then which gives you 1 over x. So for dv dx, when you try to do integration, you will be able to get x. So now let's try to put them back into the formula. So ln 2x dx will be equal to u times v. So x ln 2x and then minus. Okay, so what do you have for v and du dv? So you have x and 1 over x. Okay, so x ln 2x and after that minus, so you need to integrate 1, right? So when you integrate 1, you are actually getting x. So ln 2x minus x plus c. So same thing, if you want to simplify your answer, then it will be x ln 2x minus 1. Okay, and let's move on to E. Okay, so for E, I would like you to try out yourself first, okay? Because it's like quite similar with what we have in front, but after that you will realize you will have some issue when you continue on, okay? So I'm going to fast track the first part, then after that, please try it out by yourself. Okay, so I think you are able to actually do everything up to this point. Okay, so I hope that you have get what you need over here. Okay, so now you will realize that you have one issue here, which is even until this step, right, you still can't integrate it because you see you still have 2x and then another e2x. So how are you going to do that? You need to do one more time substitution by parts. So meaning that for 2xe, 2x, I'll need to do another time. So u equal to 2x and then after that du dx equal to 2, and then dv dx is e2x, and then v is 1 over 2 e2x. So after you have done this, then you can continue now. So the same thing here. Okay? Okay, so continue. X squared minus e2x, then minus. Okay, so you see this is the part that you need to do integration by parts again, right? So that's why a big bracket. So u times v. So 2x multiplied with 1 over 2 e2x, then minus integration for these two multiply. So 1 over 2 e2x multiplied by 2, and then dx. So close your bracket. Okay, so meaning that I'm trying to fix everything into this part now. So let us continue. So you have x squared e2x minus x e to x, and minus minus, this will become plus. So e to x dx, and you will realize that this part is something simple enough for you to integrate directly. So that's why you do not need to do any more by parts again. So now you will have positive 1 over 2 e to x plus c. So that will be your last answer. So if you want to, then you can try to simplify this as well. So e to x, and then x squared minus x plus 1 over 2, then plus c. Okay, so let's try to move on to the next one. Okay, G, you can see there's a trigger function here as well. So as what I said, if you see any exponential or trigonometry, so the part should be something that should be your part for dv dx, okay? Because when you continue to differentiate it, you wouldn't be able to eliminate your sign also. But if you see x squared and you continue to differentiate, you will get 2x, then after that x. So by looking at this question, you should able to identify that you need to do 2 times of integration by parts again. Okay, so for this question, because it's the same idea, so I'm going to fast track it as well. So that's why please try to go through it by yourself. Then after that, if you don't understand, then only you refers to the working. Okay. Okay, so you should be able to identify that you can't actually straight away integrate this as well. So you need to do it one more time. Okay, so again, another reminder. So from here to here, right, you are doing integration. So the integration for sine x is negative cos x. Okay, so don't confuse with differentiation and integration. So let's continue for second time. Okay, so you will realize this is something that you can integrate now. So you do not need to do by parts anymore. So straight away, you can integrate this. Okay, so this will be your last answer. Okay, so since you don't have any common factor already, so I mean you can't take out the cos or sine or even 2 or x, right? Okay, so that will be your last answer. So let's try to look at the last one. Okay, so for E, you will realize that for these two functions, right, it is something that you can differentiate and also integrate. Okay, so it's exponential and trigo. So how can you actually identify it? So in this case, actually, whether you go with e2x sine x or sine x e2x is still going to give you the exactly same answer. Okay, so that's why by looking at this, then we will just follow the questions here, then we try it out. Okay, so I would like you to try out yourself, and then the same thing, you might need to do 2 times integration by parts here. but then you will realize another issue here. Okay, so that's the reason that I try to arrange the questions like this, and after that for your age you will realize you have some new issue here. Okay, so same thing, try to do the integration by parts for yourself and check your answer first. Okay, I hope that you have successfully get to this point. So you can realize that you have some problem here, which is for this part, right? You see, it's still something that you can't integrate. And then a very important issue here is if you realize, right, this term is basically the same thing with what you want to solve at first. And you will realize that if you continue to do this, right, it will just keep you in a loop, which e2x will forever be e2x, and then sine x will alternate between cos x, sine x, cos x, sine x, and you will never get to an end of this answer. So how are you going to do that? So this is a questions that something is like very special. So what do you need to do here is, if you realize, right, this is what we want to solve, and now you have reached this step, and this is basically the exactly same thing with this. So what do we need to do is we need to solve it like an equation now. So we know that this we can always just copy one more time over here, right? Okay, so since you have one time of this and this is 4 times, so can you try to combine them together? Yes, you can. So meaning that the integrate for e2x sine x dx. So you move the whole thing here to the front. So plus 4 e2x sine x dx. Okay, so the other thing you can just copy it. Okay, so now can you try to simplify that? So 1 plus 4, you get 5. Right? So what can you do with the 5? Because what we want to find, this is what we want to find, right? We don't want to find 5 times of that. So that's why when we try to move it to the other side, it will become divide. So this is how you will get to your answer. The integration for e2x sine x dx will be actually equals to what? Negative 1 over 5 for the whole thing here. So maybe we can try to do the, okay, we try to multiply first, then after that we only do the simplification. Okay, so plus 2 over 5 e2x sine x, and then plus c. Okay, don't forget you have a plus c over here. All right, is that okay? So if you want, you can add a plus c over here also lah. So it means the same thing. Okay, but just don't forget your last answer, you should have that term. Okay, so this is what you want to find. So now you get your answer already. So if you want to, then you can try to further simplify your answer, which you can see you have 1 over 5 and then e2x. Okay, so you have negative cos x and then plus 2 sine x. All right, so that is your last answer. Okay, so let's try to move on to the next questions. Okay, number 2, this is a similar questions with what we have done just now in 1H. So if you want, then you can always try to do it by your own first before you check your answer here. Okay, so same thing, you have I, so I equal to ln x over x dx. Okay, so same thing, uv. So since that we know that this one we can always solve this in like 1 over x and then ln x. So but ln x cannot be integrated, right? So that's why it should be ln x, then after that 1 over x. Okay, so now we can continue. U equal to ln x, and then dv dx equal to 1 over x. Okay, so du dx is 1 over x, and then v equal to, so what is the integration for 1 over x? You get 1 over ln x as well. Okay, so now we continue. So x over x dx. So u times v, so you get 2 times of ln x. Okay, and then minus, so v times du dx, so ln x over x. So what do you realize here? So you can see that you get exactly same thing for these two terms as well. So you can try to combine them together, so it becomes 2. Okay, so you already know that if you continue to do by parts, you will get the exactly same thing, right? So if you continue on, so that's why you will need to just stop here, then you solve it. So plus c. Okay, so as you move on, so given the question, given that I is equal to the integral for ln x over x, right? This is what is given in the questions itself here. Okay, so that's why we can just continue. So you have your 2i equal to ln x 2 plus c. Okay, so I will be equal to 1 over 2 ln x squared plus c. So you get what the questions want you to prove. So I equals to 1 over 2 ln x squared plus c. All right, so let's move on to the last question. Okay, number 3, I definitely know that you should be able to solve this, but I'm just putting it here so that I just want to explain a little bit like how you actually write down your answer. So like the solution, how do you actually make it in an organized way? Okay, so you know that you are going to actually solve for a finite integral, right? So which your limit is like from 1 to 2. But then if you try to put everything in like one shot, then it might look like very difficult for you to actually solve it. So that's why I recommend you, right? So if you have a finite integral, so you try to solve it as if like a infinite first. So mean that you don't put in your limit first. So until you solve it for what you need, then only you try to sub in. So meaning that you already know that for this point you are going to solve for ln x, and then after that multiply with x cubed. Okay, so as you move on, then you have your u, then u equal to ln x, and then dv dx equal to x cubed. Okay, so du dx will give you 1 over x, and then v will give you 1 over 4x power 4. Okay, so you can continue x cubed ln x dx. So u multiply by v, you get 1 over 4x 4 ln 4 minus, so you have 1 over x multiply with 1 over 4x power 4. Okay, so the idea is that, you see, if you try to put your limit now, right, you will realize you will need to draw the box. Then after that, inside here, whether you write or not, then you feel confused as well. So that's why you just try to do it like without the limit. Then after that, you only put in the limit after you solve everything. So x 4 ln x, then after that minus, so you have 1 over 4x cubed dx. Okay, so solve it. So here you will be able to get 1 over, divide by 4 again. So that's why plus c. Okay, so until you get your last answer, then only you try to put in your limit. So that will be much more easier. So 1, 2, x cubed ln x dx. So now only you try to substitute. Okay, so you can substitute over here. So you have 1 over 4, 2, 4, ln 2 minus 1 over 16, 2, 4. Okay, sorry, then for here you don't have your plus C already lah. Sorry, my mistake. Okay, so for this part, you are going to minus for the 1. So ln 1, you know that you are going to get 0, right? So you can just 0, then minus 1 over 16, 1, 4. Okay, so as you move on, then I guess you will get 4 ln 2 minus 1 minus plus 1 over 16. So your last answer should be 4 ln 2 minus 15 over 16. All right, so I think it wouldn't be any problem for you. It's just that the way that you are going to write it. Okay, so it's simple that you just solve it as normal. Then after that, you just sub in your limit. Okay, so let's move on to B. Okay, so B is the same idea as well. So I'm putting in this question because I want you to get used with the positive and negative for the differentiation and the integration for the sine and cos. Okay, so I will fast track the whole process. So please try to check your answer after you have finished your working. Okay, so I hope that you will be able to get the answer. So I think just make sure that your positive sign and your negative sign is correct. So that's the idea. Okay, so something that important is when you try to substitute, right? So I know sometimes you do not want to like copy so long. So meaning you or it's not necessary for you to like do like negative 2 then 1 over 2 pi cos 2 1 over 2 pi and so on, but you need to have one step that show you are doing the substitution. So please do not leave the whole step like blank then after that straight away give to the last answer. So you still need to show the effort that you are going to do substitution, although it's not like writing the whole thing again, but the idea is that you need to show that you are doing the substitution even you do some mental calculation. Okay. Okay, so the last question. So this question is for the infinity as the upper limit. So that's why I'll show you how to do the infinity part. So at the same time, so please try to do the substitution by parts by yourself. Okay, I hope that you can get to this point by yourself. So let's try to put in the limit now. 0 infinity x e negative ax dx equal to okay. So now you need to imagine that when you try to substitute 0 and infinity inside, then what do you get? Okay, but normally for the infinity part, of course, we are not going to substitute exactly the infinity there. So that's why we need to try to think of when your x is approaches to infinity, what will happen. So you know that you have previously learned what is the exponential graph, right? So the exponential graph looks something like this. So you will have a point where, so something like this. Okay, so this is like your 1, the intersection point here. So for here, it will be like approaching to your x-axis, but it will never reach that. So when x approaches to infinity, e to the power of negative x will approaches to 0. So as what you can see in the graph lah. So meaning that we also know that if e negative ax is going to be approaches to 0 as well. So that's why we know that when we substitute when we want to put x approaches to infinity, right, this part will approaches to 0 and this part will approaches to 0. So that's why 0, infinity, x, e, negative ax. So let's continue. So you know that this part is going to be approaches to 0. So negative 0 minus 0. Okay, and after that, let's look at the 0. So you can see 0 over a. So maybe you can just write down first. So you have negative 0 over a e to the power of 0 minus 1 over a square e to the power of 0. So 0 over a, you are getting 0, right? So that's why you only left with this part. So e power 0 give you 1. So that's why your answer will be 1 over a square. Okay, so that's it for today's lesson. So please try to spend your weekend to finish your homework and so on. So if you have any question, then feel free to approach me personally. Okay, so that's it. I'll see you on Monday. Thank you.